So I'll just go through today's focus, that is introducing Python for geologists or engineers. And I think this is the second session organized by Wigate. The last session was more focused on intro, giving you an intro and overview of what data science is, data analysis is, and things like that. Let me share the link to this notebook I'll be going through so that you can follow along. So I have it on my GitHub page. You can click on the link to follow. And one thing I tell people, whenever you have such Python classes, because it's practical, it's good to follow along. It's not it's a lot of people want to, okay, let me just get the knowledge. When I have time, I'll go through whatever I've been taught. The truth is that you almost never go back there, and you get to consolidate and solidify your knowledge when you practice along, and you can always refer back to your notebook rather than just listening just to listen in. Okay, so we'll be going through the topic. Focus for today would be introduction to Python, just getting started, understanding Python, what Python is, the syntaxes, different variables, different data types, and basic operations. And if we have time at the end, we can also go into some data analysis, analyzing some geoscience or geology related data, but it depends on how far we can go. Okay, so I just wanted to introduce integrated development environment. With Python is a programming language, and there are different platforms where you can write and edit your code. So we have Jupyter Notebook. I think that's what a lot of people are familiar with. Jupyter Notebook or Jupyter Lab, you can download that. Or if you download the Anaconda package, you have access to different IDEs where you can start writing your code. You have things like Visual Studio Code, and that's what I'm using now. So if you look at my environment, this is a Visual Studio development environment. We have Spider, we have PyCharm, and a lot more. I think these are some of the common ones you find people using. Then we also talk about some different Python types, file types. So you have like a Jupyter Notebook. So this, what you see now, is a Jupyter Notebook. With a Jupyter Notebook, you can write code and you see your results on the same code block. And that's what I really recommend for people. Why for Python file.py file? So for example, you're writing your code with something like with Spider, you have Python files where the way you write your code is different, where you see the output of the code is different. Maybe sometimes it's segmented into like 4 or 2, depending on how you program. So that's different. They also have Markdown. So this notebook I'm working on, this is a Jupyter Notebook. So I'm using a Visual Studio Code IDE, and I'm working on a Jupyter Notebook. So if you look at the name of this file, you see it is .ipynb. That shows me it's a Jupyter Notebook. You could also have like a .md file. This shows like a Markdown. So in coding, there's what we call Markdown. So that's where you just write. When you don't really want to code, you want to just write maybe description of things. So this is what the Markdown looks like, and you can, for example, I want to see how this will come out. So this code here, this is how it comes in, where you have you have things like your headers. When you use like one hash, gives you like the heading. So it makes everything understandable, put things in different sections. You have headers. If you use like 2 hashes, you see as we go through, then you could also include images, videos on your Markdown file. Okay, so I've talked about that. Then when you talk about Jupyter Notebook, there are 2 main types of blocks or what you can write. So we have a Markdown, like this is a Markdown. So where I told you about, so it's if you want to write headers, have subsets, you have, for example, let's see, getting started with Python, you see it has one hash. I have 1 hash on it. Then everything under the next has like 2 hashes. So it shows that it is under. So it just gives your code block hierarchy. So for example, I have everything under here would be like 2, the second level header. So if you work with Microsoft Word, for example, you still have those sectioning to understand your code block. So you have a Markdown. Markdown is where you write maybe description of your code or what you're doing, while the code block in itself is where you write your code. For example, if I have a code and if I write this, I say I want to write this in a code block, it's going to return an error if I try to run it. You see, it's already highlighting because this is not supposed to be in a code block. Okay, so if, for example, you want to also write description in your code block, you just use hash to, so that part of the code wouldn't run. So any part of your code you can also describe what you're doing inside the code block, but you have to hash it so that it doesn't run. It's called commenting out the code. Okay, so I think that's just a brief overview of Jupyter Notebook, so that when we start writing things out, you understand hierarchy and different things. So let's just go into some basic Python syntax. Initially, you can have print. So print is used to print out an information. So for example, I want to print out welcome to Python for geology. You just put print. This prints Allah for you. So whenever you want to see a result of something, you can always print to see that result. Then we have input. When you want to ask the user to input something. For example, if I run this code, you see it asks me to enter something. I can choose to enter, let's say, enter a number, and it prints out, okay, that's a number. Then I can, if you use input and use like a text inside of it, so you have to go into strings later, it will ask you. So when I run this, it asks me, what is your name? So it depends on whatever I have there. So I can say my name is Promise, put in Promise, and it returns that Promise. Then I just go into variable, data type, and basic operations with Python. So variables are used to store information. You can have, like, there are different ways of naming variables. So if you want to assign an information to something, you assign it to a variable. So you can have different kind of variable. You can have short name variables, like say x equals to something, y equals to something, z equals to something. Those are variables. Then in some cases, the variable names could be more descriptive. It could be my name, or it could be age, it could be total volume, it could be something regarding that explains what that variable contains. But in other cases, it could just be one letter and short names like that. Then there are some rules. So when you want to name your variables, there are some rules that you must use. For example, you can't start a variable name with a number. It's going to flag an error. It must start with a letter or an underscore. And variables only contain alphabet and numeric and an underscore. So for example, you can't have column in your variable name. You can't have dash, like hyphen in your column name, or semicolon in your column name. So it has to be either letters or numbers or underscore, but it shouldn't start with a number. And also, variables are case sensitive. So for example, if you have a variable age with a small letter and a variable age with a capital letter, the program recognizes those two as different variables. And in Python, there are certain keywords. A variable name cannot be a keyword. For example, print is a keyword. You can't name a variable print. So those are some things you have to take note. So for example, some right ways to name variables. So for example, I have a variable called my var. You could have it as this. You could have it with an underscore. So these are just different ways to name variables. The same, and with the way we have them, the computer recognizes them as different items in the program. So these are some wrong ways. For example, starting with a number, you see that it's already highlighting that it's wrong. Using like an hyphen is already recognizing that as a wrong. Then using a space, so you can't use a space in your variable declaration. So these are some wrong ways that you need to avoid while writing your variables. And there are different ways to name variables. So if you have multi-words, so most of the times you try to make your code understandable and readable. So if you want to name something, for example, you could say hardness of quartz, for example. You want to explain that so that whoever picks up that code understands that this is what this. Just say maybe x equals to something. Somebody might come and not understand what x means, except you start adding explanation. In this case, x is depth of water or depth below sea level. So in other case, you can just put depth below sea level as the variable name. So if you have, in those cases, how do you name your variable? So there are different ways to go. There's the camel case, where every new word begins with a capital letter, but the first word would be a small letter, like you can see in these different options. So every new word begins with a capital letter. Then we have Pascal. It's almost the same as your camel case, just that in this case, every word, including the first, begins with a capital letter. Okay, and then we have snake case. I think this is what I use most times, and what you find a lot of people using is the snake case, where every word is separated with an underscore. So you get that. Okay. So, and there's where sometimes you want to name multiple variables. So I can choose to do x equals to, let's say x equals to something, y equals to, let's say y equals to, I used banana here, banana, BANANA, and let's say z equals to cherry. So let me just copy this. You can choose to do this, but I think it's more efficient. You can also use this method to declare multiple variables at the same time, rather than specifying each of them one after the other. So if I run this, and let's see, print this, it gives me the same thing, and if I do this, it gives the same thing. So whatever way you want to name your variable. Okay, now let's go into more practical things. Now we'll be talking about data types. Data type is very key, and it's one of those fundamental concepts when you talk about programming, most especially with Python. And there are 4 main types of variables. There are other variables when you start looking at it, but as a beginner, what you want to focus on are these 4 data types. So we have integers. Integers are numbers. So whenever you want to declare a number, what comes to mind would be using integers or storing them as integers. Then we also have floating numbers. These are decimals, and you have strings are letters. So if you want to type a letter, anything that is not a number, you want to store that as a string. Then we have booleans, and they are true or false value. So they are usually zeros and ones. So is it true? Is it false? True is 1, false is 0. So let's look at integer, for example. Let me see. Okay, let's look at integer, for example. Let's say if I said the hardness of coarse hardness is 7, gypsum hardness is 2. Let's run that, and I want to print what is the data type stored stored under the coarse variable, coarse hardness variable. If I print it out, it shows that it's integer. Okay, let me just use this x for example. Just take this here and use this, and let's see, type. Let me use gypsum for example. So if I use gypsum by specifying it's 2.0, if I print the type of this, it will show me it's a float. So by specifying, I want my hardness to be, I want this variable to be float just by using 2.0. In other cases, I can choose to do, so this is 1. Let me see. If I also do, for example, I want to use this, I can use int, make it an integer, even though I specified that it's 2.0, it will return the integer equivalent to that. So it will then be integer. Or the same thing if I use this, for example, let's see, 7.0, and I specify that, no, let me use this. So if I specify that I want this to be a float, so this is called casting. So that, like, you are specifying the data type you want associated with that variable. So in this case, I'm putting, even if I'm declaring it as 7, but I say return the float equivalent of 7. So if I print this, it's going to return it as a float. So these are different ways you can specify a variable. Okay, then also we have string. String are used to store letters, information that other than other than integer or numbers. So for example, I say the mineral is quartz, color is colorless. And when you talk about declaring a string, a string variable, you can use it with either the double quote or a single quote. Regardless, it still means the same thing. So it depends on which you prefer using and the case scenario. Okay, so for example, if I run this and I say what's the type of mineral, it returns that the type of mineral is a string. If I run what's the type of color, is also a string. I can choose to print what is color, what's the color. It prints out color is colorless, so that's what I've declared as color to show what that is. As other than having this single or double quotes, you also have triple quotes. Triple quotes are used to store multi lines. So if you have multi, like a sentence or a page of full of information, you want to store it as a triple quote, because with that you can have multi lines. So for example, let's try the same thing, but let's use a double quote, for example. So it's already returning an error because it expects because I'm using a double quote, it expects it to be just one line. Then when you start going into new lines, you'll have issues. So I can choose to then make this a triple quote. So I can, with the triple quote as well, you could use either the double triple quote or the single triple quotes. So by the time I'm using triple quote, you see that those errors have gone out. So with good thing about VS Code is Visual Studio Code, it helps you debug. So what does debug? Debug means when you have errors in your code, instead of waiting for you to run it and find the error, it highlights that, okay, there's a problem here. This is what you wouldn't find this feature when you're working with the Jupyter Notebook itself or Jupyter Lab. But with VS Code, it has an inbuilt debugging. So that's why when you start seeing your kind of highlighting errors, you know that there's something that you need to fix. Okay, so that's it for mod. So in this case, I also print it and it's also a string. So either way, just know that there are different use cases and choose the one that works for you. Okay, then we also have formatted string. Formatted string is if for example you want to print a sentence, but inside the sentence you want to include a variable in it. For example, I have my variable mineral. Let's see, I have my variable mineral. I have another variable called hardness. Let's see, I have another variable called hardness. Okay, because so it's returning, and you see this is already highlighting because it looks before it there is nothing called hardness, but you see that the hardness was declared after that block of code. So that's why this is returning an error. So whenever you do your code, make sure you have it before. You have to call the variable after you have declared it. Okay, so we have hardness as 7, and we have let's see, we have color as colorless, for example. But now I want to print out like a sentence that describes, that combines these different variables. So there are different ways I can go about it. I can say, let's say, print mineral. So that's the mineral itself. I can do a comma. I can print, and I put in a string and say, okay, has a hardness of, then I come again, do a comma, then type in hardness. So it's more like printing out the information stored. Then I can do a comma and is color. I'm going to put the color. So because an is not a variable, so it's a string in itself. So I have to. So notice every new block of every new item I put a comma. So this is just printing out the information there. But I can do this in a more efficient way by using a formatted, it's called formatted string, where you can type in words and also call in variable. So you have to use the F keyword. So with the formatted string, if you want to put in a variable, it's like a string, but it's formatted. That means you want to show that I can call in some variables inside that string. So in this case, you use the curly bracket to specify that, okay, this within this block, use a variable that's been declared in this notebook already. So that's what your formatted string, what you can do with formatted string. Then we talk about Python operators. And so with Python, you can do the basic operations. You can so addition, subtraction, multiplication, division, things like that. But we'll go into then we have some conditional statement where you have equals to. So using equals to is it will return either a true. So double equals to. So when you're using a single equals to, it shows that you're declaring a variable. Creating of variables is more like declaring an item. So for example, if I say name is equals to, so you put your name, so the computer understands that whenever I call name, this is what is associated. It's like storing things inside container. So for example, in your house, you have containers for storing different food items. So you know the container for storing rice, for example. Whenever you whenever you need rice, you know that, okay, this container stores rice. So the similar ideology with variable. Variables are used to store different information, and you want to name your variable something that you can understand. So for example, if you have a container, sometimes some people put label rice, so it shows that this is rice. So whenever I want rice, this is the container I need to go. So you can say name. Name is equals to this variable. Whenever I need name, I just call on name and it returns whatever I've stored inside name. You can also have variable called age. It's not as this variable contains age. And with variable, you can declare different data types in a variable or different data structures inside each variable. Just see variables as containers for storing information.
Hello.
Yeah, I can hear you. I'm just trying to see how I can break it down further. So I mentioned 4 main types of variables. We have integers, and when you think about number 1, 2, 3, 4, 5, 6, 7. So if you have to, I mentioned initially that variables are used to store information. So if I have something like a number and I want to store it in a container, the data type in that container should be integer because it's a number. So that's whenever you hear numbers, what should come to mind is integer. Whenever you hear floats, that's decimal. So it's still numbers, but decimal. So integers are whole numbers. But when you start introducing decimal, be it 1 decimal up to infinity decimal, it's floats. So it's floating number. So that's what you think about float. Then when you start talking about letters, the name of something, what kind of food do you like, or what kind of car do you drive, where do you stay, those whatever you have in that information is not number, so you have to store it as strings. Then the last is booleans are used to show it's either true or false. Booleans are either true or false. So I think that just sets that, like, okay, understand those different fundamental concepts, because on those other things are built upon on those concepts. Okay, then we'll start looking at conditions. So there are different conditions. So I use one equals to sign is used to declare a variable, but when I'm using two, it's more like asking the computer, is this equals to this? So for example, let's print, what are the things we've printed before? So mineral, so I want to check mineral equals to hardness. So what this is asking is mineral equals to hardness. So if it's true, it returns true. So if I have the same thing stored as mineral and hardness, it will return it as true. So it's not looking at the name of the variable inside, but what's stored inside that variable. So it shows false. Then there is a not equals to. So it's asking, is this not equals to XYZ? So in this case, it will be true because mineral definitely is not equals to hardness. So these are basic concepts that we get to build on later. Then you can see if it's true. So using less than or equals to, it's where you can start looking is when you look at numbers. So that's when you use either equals to or greater than or less than. When you start looking at its number. So for example, I have hardness. Let me try hardness greater than, let's see, hardness greater than 10. So it's asking, is hardness greater than 10? If it's true, it returns true. It's false. So let's print out, what do we have as our hardness? hardness is 7. So it's asking if hardness is greater than 10, it says false. But if I put hardness less than 10, this will return true because hardness is 7 and it's less than 10. So that's how you use that. Then let's start looking at some calculations. So you can do calculation, multiplication, division. So for example, we've declared quartz hardness initially. Quartz hardness. This is quartz hardness, and we have gypsum hardness. So you can say quartz hardness minus gypsum hardness. Let's see. It shows 5. That means it's 7 minus 5. In some cases, I can choose to use the addition sign to see how to just to add some things up. I can also choose to use sum to say quartz hardness. Let's see. In this case, I'll just use a comma. So I want to sum these two items together. Okay, float is not iterable. Okay, so not this. So I can choose to not this. Let's do this instead. So I have to put it in a tuple. So it's also some things together. I can choose to, you can multiply. So it's multiplying those two items together. Or you can choose to divide. You can choose to divide. So using all the signs, it divides. So this will be 7 divided by 2, 3.5. So there's also, you can also use the modulo sign to return the remainder. So if 7 divided by 2 would be 3, remaining 1. So if I use this, it returns only the remainder. So it returns that I have 1 remaining. Or I can use the double division sign to return only the whole number. So just want to get the whole number. So in this case, we return 3 because 7 divided by 2 is 3, remaining 1. So the double backslash or forward slash returns the whole number, but the double but the modulus, and that's the percentage sign, returns only the remainder when you divide something by something. Okay, so now let's start doing some calculation. I try to use some scientific calculation so that at least as scientists we can relate to these engineers. So for example, if I declare my mass as 150, so I'm declaring, so what would be the data type? What would mass be? What would be the data type of mass? I need response. If I declare my mass equals to 150, what would be the data type stored in here? That would be an integer. For example, mass would be 150, that would be an integer. Volume would be 100 because it's also an integer, but G would be float. So also I mentioned initially that you can use commenting to explain your code. So for example, this mass is in grams, so I use this hash can, so the computer wouldn't run anything after this hash. It's just more like explaining what that means. So for example, I have my mass 150, 150 but it's in gram. I have my volume in cm cube or cc. Then I have my G in meter. So now if I want to calculate density is mass over volume. I just divide my mass versus volume. So if I do this, return, so I'm also storing my density as density as a variable, but the variable will be dividing mass divided by volume. And I have 1.5, and this is in gram per cm cube. Okay. Then also I could have the same thing as, for example, I have my depth at 300 meters. So what's pressure? That's density, depth, that's density, height, and your acceleration due to gravity. That will be depth times density times acceleration due to gravity. That will give me a pressure at 350.
Sorry, please, I have a question.
Okay.
When declaring the values of this mass, volume, and the other G, why is the ash? Why is the ash there? Like 150 ash in grams. Why is the ash there?
So I mentioned that hash is used to. So whenever you use hash, the computer recognizes it as don't run this part. So hash is used to comment the part of the code you don't want to run. So for example, if I take out hash, you see it's already highlighting error because I have a debugging tool on this. So if I run this, it's going to return an error because the computer does not understand what is grams. I've not declared it as a variable, but that's why I use hash. So it's more like giving an explanation to that block of code. So if I give you this, for example, you can say my mass is equals to 150, but I also gone ahead to say that the mass is in grams. So that's what this hash does. It's just more like commenting, explaining what that does. You don't have to have it there, but it's just like when I mentioned, when you start writing code, you want to make it clear enough so that sometimes you can even write a code and you come back in, let's say, 3 weeks and you can't even remember. Oh, mass, what was the mass again? Was it in kilograms? Was it in grams? So that's why, where possible, try to add little explanations in your code for understandability and readability. So that, then you can also, so in this case, so you notice that I did this and it's just specifying the units. So, yeah, so that you know the units where you have that. So for example, in this block of code, the computer didn't run it because it's hashed. That's more like exempt this from whatever you're running. So if I take it out, it's going to be an error. It's like, okay, what is this? I don't understand what this is. But you have to. So that's where you comment so that, yeah, you don't run this part, exempt this part when you try to execute this code. So the same thing, you can calculate the pressure at a depth of 350. Okay, so let's do some more calculations. So for example, you can also calculate your porosity. You understand porosity is the percentage of void space in the rock. So if you have a rock, you have the total volume of your rock and you have the number of void spaces, you can use that to calculate for porosity. It's just about declaring the right variables and doing your calculation. I don't know, before, at least we are science students, we know how to calculate and we know how to at least do this on paper. So now just let's see how we can do this using code. So for example, we have the volume of void to be, let's say, 10 centimeter, and the total volume of that rock is 100 centimeter. You want to calculate, and this is the formula to calculate for porosity. So it will be the volume of the void divided by the total volume of the rock times 100. So you can use this. So um, using this curved bracket, it's just more like, okay, execute this part of code separately, then do this separately. So that it's just making sure you have the right answer. So you to first divide volume of the void divided by the total volume, then multiply by 10 by 100. And when I run this, it shows that I have 10%. That's porosity of this rock. Okay, so let's try something else. So I want to see screenshots in the comment section. So let's say you have your volume of your rock as 250, right? And you have your total volume of void as 50. What will be the porosity? I want to see screenshots in the comment section. So I'll give you about 5 minutes to do that. So let's say volume of void in this case would be 50, and we have total volume of rock equals to 250. No, this is to be the same thing. Let's not make it 250. Let's make it 300. I want to see screenshots of your answers. Okay, so you have two exercises on the screen. I want to see your solutions, like screenshots of your solutions. So we've talked about different data types. I've mentioned 4 main data types. There are other ways where you can also store data. We call them data structures. They are used to store collection of items. So, and there are 4 main types of data structures. We have lists. Lists are created using square brackets. So, and each item is separated using a comma. And you can change items in a list. You can have multiple or duplicate items inside a list. Yeah, just try to take them down. Then we have tuples. Tuples are created using the curved or round brackets. When you declare a tuple, you can't change an item in a tuple, and they are all that. So every item in the list or in the tuple have a position number. We go into indexing much later. Maybe after this, I'll talk about indexing. So let me write that down so that I don't get to forget, because I think I didn't include them down. So let's talk about indexing here. Indexing. Okay, so we'll come back to indexing. So let's just talk about data structure. So we have lists. Lists are created using the square bracket. We have tuples are created using curved bracket. We have sets. Sets are created using the curly brackets, And dictionaries are created using a curly bracket as well. But I will explain what they, so just understand, okay, how they are created. Then we can now start talking about, because they all have their unique properties and characteristics or behavior, how you can access item or what you can do with these different data types. Okay, so for example, we have a list. I mentioned a list are used to store items, and they are created using a square bracket. So a list can contain different data types in it. So I can let's try something. Let's say my list. Let me just create a new variable called my list. I said they're created using square bracket. I can say let me put a variable called name. I can put another variable called fruits. I can put in another variable. I can put a number as a list. I can put a float as a list, and I can use true, boolean. So this list contains different items in it. So whenever I call or print out my list, it prints out all the items I have in my list. Okay, so let me just put a duplicate item as well there. So I have this item as my list. Then if I want to print type, I want to see what's the type of my list, what type of variable is my list. So using the type ask you what's the type of variable in the list. My list, it's a list. So in this other list, I have minerals. So whenever you just see something with square bracket, what comes to mind? A list. Okay, so I can say minerals. This is a mineral. Then if I say, okay, let me see what's the type of data in minerals. Minerals, it shows that it's a list. There are different, you can also, okay, let me leave that aside. Then, so, and there are different methods. So when you talk about different data types, there are different things you can do with a list. For example, you can sort. For example, I have minerals as quartz, gypsum, calcite, fluorite. If I use mineral to sort, it sorts the list, and it sorts it in alphabetical order. With minerals, you would a list. You can also add items to a list by using the append. For example, I can say minerals.append. That's more like I'm adding another item to the last part of the list. So in here, I have minerals as calcite, fluoride, gypsum, and quartz. Then if I say minerals.append halite, it's going to add halite to the last position in the list. So it sees it now. It has added halite as part of the list. So you use append to add items to a list. You can also remove items from your list by using the list dot remove the item you want to remove. Then you can add two lists together. I can say mineral dot extend. So using the dot extend. So these are different. I don't expect you to memorize all these methods. It's just for you to understand that this can be done. Then whenever you're ready to do, for example, I'm trying to let's say after now you pick up a Python script and you're trying to add items to a list. You can see, I can't remember. I know that I can add items to a list, but I don't know how to add items. That's why you have internet. You can just go online and I can show you an example of how to, let's say, let me create a new, let me put this here. For example, I said I want to add an item to a list, but I can't remember how to add item. I'll say add Python, add item to a list. All I need to do is go search. So there are different platforms where you can, so you can just come. I think I use Stack Overflow a lot. You can just come to Stack Overflow, for example, and see, just scroll through. For example, you try to, you want to look for the ones with this tick, this green tick. It shows that, okay, whoever asked that question, this was the answer that gave that person that was the answer that, and that was the response that answered that question. So you could see list.append. So there are different ways to go about it. You can also insert that. Those are other methods. Or better still, you can also come, let's say, if you can go to the list documentation to see list method. You can use W3 Score. It's also a good platform. It shows you, okay, what I can do is I can append items to a list, or there are different ways to add items to a list. It just gives you the different options. So that's where, so I don't expect you to memorize everything you can do with a particular data type or a data structure. It's about knowing what's possible. Then whenever you need to use it, you can always go browse and ask questions, to be honest. Okay. And then I talk about extend, so you can add another list. So extend would help you add a list to a list. So I have, for example, I have this list, my lists. So by extending, so let's see, if I print out minerals now, you see that I've added whatever I had in my list to minerals. Okay. Then I also talked about tuple. I think I talked about tuples. Or tuples are also used to store items, but with tuple you can't really change items once you've declared it. So if I say my tuple, let's say my tuple, so it's just you can call it whatever you want. So I can use this curved bracket to specify whatever I have in my tuple. So I can choose to print out my tuple. Then I can also print out the type of data, my tuple, then put type, my tuple. It shows that it's a tuple that you stored inside. So with tuple, you can't really change, once you've declared a tuple, you can't change the item in a tuple. So that's something you should know about tuples. Then we have sets. Sets are used to store items similar, the same way you have your lists. But one unique thing about set is that you can't have duplicate items in your set. For example, let's go back to this. So I declared this as a list. If I want to declare let me call something else. So let me just call this my list as well, so that you know that it's not about what you call. You can call it different things. It depends on what information do you have inside. So in this case, I have this item as my list. So this is I call it my list. So it's not about the name you call it. So for example, I have this. So I have 2 tools. I have 4 and I have true. No, sorry. This is supposed to be a curved bracket now. This is supposed to be a curved bracket. Okay. So I have this as, so I want to say what's the type of my list. It shows that it's a set. I noticed when I printed out the set itself, even though I had 2 tools, it only returned 1, and it sorted it in alphabetical order, or if it's numbers from smallest to largest, and with the alphabet, it has sorted that alphabetically. Okay, so a take-home assignment could be for you to go research or find out the data structure methods. What are the methods you can research, you can use on the different data types? So we've talked about list, sets, tuples, and also look at dictionary. So you say that, then we look at dictionaries. Remember I said dictionaries are used to store collection of items. Yes, and they are declared using the curved bracket similar to the set. But the difference about set and dictionaries is that you have what we call key value pair. So you have a dictionary, we have a key and a value. So dictionary, you have, rather than just having items, you have a value. So I can say, let's just pick out this as a dictionary, for example. So let's see, let's call this dictionary quotes. It's equals to this, and I put, okay, let's say quotes has, let's take out quotes. Okay, so now in this case, in this dictionary, we have 3 items in the dictionary. We have 3 items, so this is called quartz. And we said the hardness of quartz is 7. What's the color? The color is colorless. So I think this. the color is colorless. So let's put it down. So we have two items in the dictionary. So we have hardness and color. So if I print out quartz, for example, it prints out that dictionary as that. So it shows me, it's used to store. So the key in this case, so the first item is always the key. It's separated by this hyphen. Is it hyphen now? Yes, not hyphen. I'm always forgetting the stems. Column, yes, separated by, thank you. Separated by this column. So you have hardness. So this is the key, this is the value. In this case, this is the key. Color is colorless. So you always separated by the column. So if I print out what's the type of quartz now, if I print out what's the type of quartz, it shows that it's a dictionary. Is that clear enough?
Yeah, it is.
Okay. So with a dictionary, you can also have a dictionary of dictionary. I know it can get confusing. So in this case, we have just one dictionary. In this case, we have multiple dictionaries. So we have a dictionary. The first item in the dictionary is quartz, but quartz has a dictionary as well. So it's a dictionary of a dictionary. So with quartz, so the dictionary itself, we have quartz, we have gypsum, we have calcite, but we also have items, a dictionary in the dictionary of each of the dictionaries. That can be confusing. Let's break it down. So we have minerals. Let's say we have minerals, mineral property now, mineral property. So it's okay. We have mineral property. So we have 3 items in the dictionary, but each of the item has its own dictionary. So now I can say, okay, for example, I want to pick out what is quartz. I can just I can do this. I can pick out this by using the square bracket. I can say, okay, I want quartz. So that's the key. You call in the key. So it returns quartz for you, what the item stored under quartz. For example, now I want to get the color of quartz. All I need to do is use a second square bracket and colon. I can say the color. It returns only the color. So it's giving me quartz. So this is the first dictionary key. This is the second dictionary key because it's a dictionary of a dictionary. I can choose to do the same thing, but in this case, I just want calcite. So it's already giving me this autocomplete. So it shows me on that mineral, I have 3 different keys. I have quartz, I have gypsum, I have calcite. So if I call on calcite, it returns the items under so this is the value of calcite in the dictionary, although it's a dictionary in itself. Okay, so I'll go through indexing. I think indexing is very key when you start talking about items in Python. So we'll go through indexing and we'll take a short break, maybe a 15 minutes break, then we come back to continue. So index, every item in Python has an index. Every variable in Python has an index. And index, you see it as positional items. See indexing as positional items. So let me see if I can lay out. No, I was looking if I could give if I can annotate with Teams. No. Okay, I'll try not to. So I don't know before now if you've seen what we call, if you know about number line. Okay, so when you have number line, you start from 0 to infinity, and you can also look the other way from 0 to minus infinity. So it's small, so you have 0 at the middle. With Python, it still uses the same ideology of number line. So let's see. I think I had a variable called my name. Or first, let me just call something. Let me use my name as a variable. So my name is equals to promise, right? So with promise, the computer stores every item inside this with a positioner, with a number, with like an index. So it's called indexing. Every item in my name has an index. For example, P it always starts with a 0. So the first item could be either a list or a string. Just that every item has an index, and the first item starts with an index of 0. Then it goes like that from 0, 1, 2, 3, 4, 5 to the end, so whatever number. So if I declare my name as Promise, so if I want to know what is in the first index, if I say what is the first index, if I call 0 because it starts from 0, it will return P because P is the first index. If I say, okay, let me return index of 3, so the first item is 0, what will index 3 return?
M. Small letter M.
Anybody with contrary opinion?
No.
Okay, yeah, so 3 will return the fourth item in that string, because yeah, it starts from 0 till, so let's run that.
Yes.
Okay, so if I run, let me try something. If I run index 7, what will index 7 return? What with an
I
index?
think like an error or something.
Okay,
Or not in
Because the name is not up to that if you start counting from 0.
okay, so that's going to return an error. Okay, that makes sense. At least you understand the story. So what if I return, what would I -1 return? What is in the index of -1?
E.
Maybe the P.
Return an
Clara, you're saying something.
not return an
Clara, what did you say?
Small letter
will
E.
return a small letter E.
Okay, so I think I have Python gurus here already. So when we talk about indexing, we could start from the first letter. We start 0 to infinity. Then if you're coming from the back, the first item will be minus. The last item will be -1. The next to the last will be -2. Okay, so this returns an E. So if you said that, that's correct. So what would -7 return?
Still on error.
Okay, anybody with a different opinion?
A P.
A P. Okay, so somebody said, Kelechi said error, Clara said P. Any other person? Any other person? Okay, let's run it and see. Truth or, so it returns a P because we're starting with minus. So why it's not an error? Because we're starting with -1. -1 is the last item. We didn't do -0. So coming from the back, you need it to be the length of the item. So I think that's what that is. Then we can also talk about slicing. Slicing with indexing, you're returning a particular index because these are the index of the item. And for example, I want to return a list of items. So for example, I don't want to return only the item name. I want to return like a list of items. I say, okay, give me from 2, let's say, give me from 2 to 5. So you return items from the second position to the 5th position. So that's what that is. So you can use, so this is slicing. When you talk about slicing in Python, so indexing and slicing, they go hand in hand. Then we can say my name. I can say, if I use, for example, I use just hyphen, and let's say down to 5. It returns from the 1st to the 5th position. The 5th position would not be included. So it will return from the first 4 items. So by using the column at the beginning, shows that it will give me from the beginning to the 5th index. In the other case, I can do the same thing, but I can say my name. Let's pick from, let's do 5 to the end. So just give me from the index 5 to the last. So that's what, so you can index a string. You can also index a list. So I have a list as, what do I have as lists? Let's go, what do we have as my lists? Not dictionary. So I have minerals. So the minerals is my index. So it's my list. So if I have minerals, so by the time indexing a list. So understanding index, you know that a list contains other strings inside. So by the time I'm indexing, I'm picking the first item in that. So let me just print this out. So let's say this is the mineral. So if I want to check how many items do I have in mineral, I can use the length function to check all the items I have in minerals. It shows that I have 10 items. I can say, okay, give me under my minerals, give me the third index. So the third index will be the fourth item in the list. So it turns highlights for me. I can also for example, I want to pick out the second item in the third list. So in this case, I can do this. I hope this doesn't return an error. So return. So what it picks is the first shows the index of the index of what in a mineral. What do I have in my third item is halite. But I can say okay, under the halite now, I want to give me another item. So the highlight is now a variable in itself or an item, and it's also stored in the position. It has a positional index. You can say okay, with halite, give me from the first to the third item in the item. It turns from H to L. So for example, so let's do an exercise, Chamaka now. So if I do this, minerals, and let me use, so I have items 10. If I do -5, what would be returned? Okay, let's see what that returns. That's correct. So if I do 5 in itself, not -5, what will be returned? Okay, because we have 10 items in it, so I think there's, so let me check minerals 0. So calcite, so this will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 items, but if I going from the back, it will be -1, -2, this will be -3, -4, -5, -6, -7, -8, -9, -10. I think we understand that. Any other questions regarding indexing or any other thing we talk about before we go on a 10 minutes break?